Welcome. In this video I'm going to be taking a look at this AstroAi portable freezer. So this was provided to me by the distributor, but they're not compensating me for this video and they're not reviewing it before I post it. If you find this video helpful and you want to purchase one of these, I'll put a link to it in the description on Amazon, and if you use that link it helps me out a little bit and doesn't cost you anything extra. So here on the side it says fast cooling, energy saving, environmental protection, strong heat preservation, convenient portability. This is a 15-liter model. So let's get this open. Okay, we have packing material here. I'll pull that out. There's the fridge. I'm going to pull this off my bench and unbox it and bring it up on my bench. So this had a similar piece of foam on the bottom. It has this bag on top. And then let's open up top here. Okay, and here it looks like we have the accessories. So I'll open this up, and here we have a power supply. This outputs 14.5 volts at 6 amps or 87 watts. Here we have a 12 volt adapter. This is for powering it from a car or an RV. And here's the other half, the AC cord. And looks like we have the manual in here and a thank you card. So this thank you card has warranty registration. You can get an extra year of warranty there. And here's the manual. Let's take a quick look at this. So you want to read through this. This can be used with 12 volt and 24 volt car outlets, as well as standard wall outlets. There's a table of contents, safety information, so you can pause if you want to read through that. If you do buy this, you should probably read through it all. Here's a diagram here. So the top hinges on one side, has a control panel, carrying handles on both sides, has a heat dissipation port. That's pretty important. If you're putting this in the back of your car, you'd want to leave that open so heat can get out, so you wouldn't want to butt that up against the side of the back of your car. AC cord and plug, DC cord and plug. Here's the display. We have a power button, set button, increase temperature, decrease temperature, and a USB charging port. So that's a really nice feature with the USB charging port. If you have this plugged into your car's 12 volt socket, you may normally have a phone charger in there, and this would displace the phone charger. So by plugging this in, you get a USB port on here so you can still charge your phone. And here's a chart with the size and dimensions, and here are the specs. So this talks about operation. It says connect the power supply, connect one end of the power supply to the freezer socket, connect the other end to the car cigarette lighter or standard household outlet. Press the power button to turn the freezer on to cooling mode. The temperature on the display is the current internal temperature. Press the plus or minus to set the cooling temperature. Hold the plus or minus to quickly increase, decrease temperature. First time you use the freezer, it will default to the lowest temperature, and subsequent uses the temperature will default to the last user set temperature. So that's a nice feature. Press the gear button to change the mode from eco to max. So that's energy saving mode and quick cooling mode. The factory default mode is max. Press the power button to turn off the freezer. Here it says change temperature unit. Set the freezer to the on state. Press and hold the gear button until it displays E1. Press the gear button again to toggle through the settings until the display reads E5. Press plus or minus to switch between Fahrenheit and Celsius. Has a battery protection setting. The freezer has 3-level battery protection function, which not only guarantees the normal operation of the freezer, but also protects the battery of the vehicle. So turn the freezer on, hold down the gear button until the display flashes H. Press the gear again to select a low voltage protection level, L, so it has low, medium, or high voltage protection. And this chart here shows the different voltages it's at. So if you have this plugged into an accessory port on your car, if your voltage drops below this level, it will shut off the fridge or will quit drawing power. So that's to keep from running down your battery. Now a lot of cars may only be powered if the car is turned on. So that's another thing to keep in mind. So you'll want to test that in your car. And you could always install an external outlet. I've done that in one of my cars. I have an outlet that's always on, even with the car off. So here's some troubleshooting. You could read through that. And here's the code analysis. And this talks about the warranty. So let's take a look around this. So we have a plastic tub here on the inside. It measures around 13 3/4 across. It's about 9 5/8 wide. And it's going to be a little tricky to do the depth. I'll just do the white portion here. Looks about 6 5/8 because this top here is going to recess into this beige area just a little bit. And I'll get some items to throw in here for testing too. So if we look at this top here, there's a foam gasket around here to seal. And there's little detents on the side to kind of keep it closed. So let's take a look at the sides. So here we have handles. These are very easy to lift. So this is going to be the light side because the compressor is on the other side. Let's take a look at the back. Here's a vent here. This might be the intake vent because I think it said this is the air ejection vent. And here's another vent here. So this is the side you want to have clearance on. And here are the controls. There's a piece of plastic here. I'll peel that off. Looks like there's also plastic down here. Peel that off. Here we have the socket for the power adapter. So if you're plugging this in at your house, you can plug that in with 120 volts. If you're in your car or RV, you can use the 12 volts. So I think the recommended way to use this would be to cool this down on max mode on mains power. So you plug this into the wall, cool it down, and then when you transfer it to your car or RV, if you're driving in your car, you might do it on max mode if you need to and have it plugged into the 12 volt socket. But then if you're powering this off a battery bank, then you would switch it to eco mode so you get the longest life. So I'll be testing with some power banks. I have a couple different sizes, but for now I'll just plug it into 120 volts. So I'll switch this around here. Here I have the control panel. I'll plug this into power. Okay, this clicked on, so it sounds like it's running. It's very quiet. It has a low hum to it. It's hard to say exactly what it sounds like, but I don't find it disturbing at all. Like you could sleep with this on next to you if you're the kind of person that could sleep with a kind of a white noise in the background. So this is currently drawing 36 watts at 120 volts. So if we go here, we can press up or down so we can change the temperature. So if I just want to cool this to use it as a fridge, I might take that up to, I think 37 degrees is what we have our main fridge set to, so I could do that. Now if I want to turn it off, I'll hit the power button. That turned it off. Press it again, turn it back on. So we can see the internal temperature is at 69 degrees Fahrenheit. So if we want to change to that eco mode, let me look that up again real quick. I want to press the gear button. Okay, so I pressed it once, pressed it again, we went to eco mode. So it may be kind of hard to see, but down here it says max and eco. And on this mode, it's going to draw less energy. But since I'm plugged into 120 volts, I'll just set it to max. Then we also have the USB port here, so you can charge your devices. So I'll be running some tests on this and gathering some supplies, but I'm going to cut the video right now and then I'll pop back in with the results. Okay, so I've got some 12-ounce soda pop cans here. And if I calculated this out, it should hold about 18. I only have 12 here, but I imagine you could put some here. And that's when putting them in like this, if you set them on their side, a different amount might fit in here. And needless to say, you don't need ice with this because this is providing the cold, not ice. Here I have a gallon jug, so this will not fit in upright. It will fit on its side. It won't fit in any other orientation except for like that. So this isn't really made for carrying jugs like this. I'm just showing it so you can see the size comparison. So if you did put a jug like this, you want to make sure the lid was not going to leak. So I probably wouldn't trust something like that. And here is a 20-ounce water bottle, and that fits in there pretty good. There's, I don't know, about 3/4 of an inch there. It'd fit 1, 4 or 5 across the bottom, and then maybe about 2 or 3 high. Then I have some sandwich containers here. So those will not fit in this direction, but they'll fit in like this. Then we could, put some water bottles here and some other food. So I did run some tests on this in my basement here, which is around 70 degrees, might be slightly cooler. When I plugged it in, it got down to 37 degrees in 20 minutes on eco mode, and it got down in 15 minutes on max mode. Then I did the test again, taking it down to -4 degrees, which is the lowest temperature. In eco mode, it took 47 minutes. In max mode, it took 34 minutes. So what I was doing there is I wanted to see how long it took to get this down to temperature when I plugged it in. So say I was preparing to have a picnic. If I wanted to get this to the absolute coldest temperature, I'd want to plug this in 34 minutes before I'm leaving. I'd probably do it an hour ahead of time just so I'm fully prepared. Then I could take this into my car, turn it to eco mode, plug it into my battery to keep it cold. So let's take a look at this with the thermal camera. Okay, so here we're viewing the fridge with a thermal camera, and you can see this is very cold here. And this is warm here, because the way a fridge works is it takes the heat from here and moves it to here. So you can see this is going to be hotter. If we look on the inside here, let's see if we can get a temp. Around 70 degrees there. This is around 50, 60 degrees. So let's just kind of look around here. We're going to see the side is also warm. Here's the power transformer. Let's look at the back side. Looks about the same. So this just kicked on. It might warm up a little bit here, but you can see there's not a lot of cold escaping here. I mean, it is definitely cooler than the ambient, but by only a few degrees. So let's open this up. Here's the inside, okay? So you can see this is around -4 degrees here, and it's about 4 degrees in the bottom. So it looks like the cooling coils are around the perimeter here, okay? And then we can see the top is going to be a little warmer here. So it looks like the coldest part of this are on the edges. Although the temperature in here is going to normalize, so everything's going to be around the same temperature. So you can see this is getting a little colder now since it's actually running. Okay, so I'm in the back of my car now, and the cooler has been off. I put all these ice packs in here to represent frozen food. So say you went to the store, took it out of your freezer. My freezer is currently set at 0 degrees, and I'm actually going to set this to -4. So this would be like if you bought some frozen things, put it in the freezer, and then you want to bring the freezer up to temperature and keep this stuff frozen. So to measure this, I have a temperature sensor here I rigged up, and I use this super thin wire so I can close the door and get a seal on it. I'll have a second probe outside, and those are going into a Raspberry Pi computer for logging. That's plugged into its own battery pack, and the freezer itself will be plugged into this power station here. So I put this in the footwell of the passenger area because this is a lithium ion battery, and I want to keep this a little bit cooler. So I can turn this on. I'll turn on the DC. I'll come over here and I'll turn this on, and it's on eco mode, and I want to leave that on eco mode since we're hooked up to a battery. So I'll make sure this is turned all the way down, so we're at -4. So now I'm going to shut this. I need to use both hands here so I can route these wires a little better. Okay, so I have the wires there, and this is just kind of hanging out on the side. So this currently says it's at 55 degrees. Then I'll take the other temp probe and I'll put it on top of the cooler. So I'm currently in my garage. I'm going to back this out into the drive. It's not super hot today, but it's very sunny. So this is going to get hot back here. Before I do that, we'll take one quick look and see how much energy this is currently drawing. Maybe hard to see here, but it's drawing 36 watts. And it says at that rate, it has 17 hours left. And this is a 634 watt hour battery. So here you can see we're in the full sun, and the sun's hitting it here. Now I do have a tonneau cover, I'm going to leave that open. So this will be more of a worst case scenario. Okay, so I have this back in my house now, and I started this whole thing around 10:20 a.m. and it's around 8:30 p.m. right now. So it's been around 10 hours or so. So my power station is currently at 40% battery left, and it's currently drawing 36 watts. So the temperature inside here says 0 degrees Fahrenheit, but remember I had this set to -4. But let's take a look at some data I collect. So here we have a chart. The top line is the external sensor, the bottom line is the internal sensor, and this is in degrees Celsius. This will make a lot of people happy, but it's not what I read. So it's hard for me to tell the exact temperature here. But you can see here they started out at about the same time, and the times on here are wrong. It says 10:13 p.m., but I should have made sure the clock was correct before I started this. But so the temperature rose pretty quick here, and it peaked out at 49.96 degrees Celsius. So that's 121 degrees Fahrenheit. So that was a sensor sitting on top of this with the sun beating down on it. And then from there it kind of dropped off, and the cooler, when it went down, it got to a point here where it stopped dropping quickly. That was -14.45 degrees Celsius or 6 degrees Fahrenheit. So it wasn't quite -4, but it was definitely below freezing temperature. And my goal was for the ice packs to stay frozen, because the ice packs represent something like ice cream. So from there, it steadily went down. You can see these peaks here. Every once in a while I'd open the lid. So that's what those peaks are. If I hadn't opened the lid, I think those would not be there. So there's a little break in the temperature there. I'm not sure what that is. So the lowest temperature right now, it's -21.57. So that's -6.83 degrees Fahrenheit. So the temperature on the display says -2, but my internal temperature probe is -6. Are these numbers super important? Not to me. The thing is, my ice packs are still frozen, and that's my goal. So I don't know where the temperature sensor is for the unit itself, and I don't know how accurate mine is. Mine's just kind of hanging off to the side. Now it might be slightly warmer towards the top of the cooler and slightly colder towards the bottom. Mine's kind of in the middle. But my goal here was to see if this would keep stuff frozen. So I have 40% left on the battery. I think I'm going to let this run all night, and then I'll come back and we'll check into it in the morning. Okay, so this has been going overnight, so it's been going over 20 hours now. If we look at my battery, it's at 0%, but it just kicked on and it's drawing about 40 watts. And well, this says 0, but a minute ago it said -2. So obviously it got a little warmer and it's kicked back on. So if we look at that chart, you can see here, once I brought it inside, the external temperature is very even now because I'm in my basement and the temperature here is probably about 70 degrees. And then it cycled on and off many times to maintain that cold temperature. So if you're camping, many times a year, the outside temperature is around 70 degrees or even lower. So you could expect a similar result to this. So this didn't quite make it 24 hours. There's a couple things I could have done. The best way to use this is to take this, cool it down all the way to whatever temperature you want it set at, put your food in it, get it all normalized, and then connect it to battery power. Also, I had this in the back of the car. If I was camping, I'd want to take this out and put it in a shady spot. Also, if you don't have a lot in it, put a jug of water in it or something and make sure that normalizes. You want to do that well ahead of time because the more thermal mass you have in it, the better it's going to cool also. And of course, with my battery pack here, I could have hooked solar into it and then run this nearly indefinitely as long as I have the solar generating energy. Now, this was at the coldest temperature. Usually when we're camping, we're not taking frozen stuff with us. So we would set this to more of a fridge temperature. So I don't know, maybe 37 or so. And that would take a lot less energy too. So I'm going to pop this open real quick. And I do want to show that these things are still frozen in here. If there's any question, if you didn't believe the thermometer that says it's frozen, this stuff is all rock hard. So that's the AstroAi portable fridge freezer. I really like the size of this. It fits well in the back of the car. Since it has a refrigeration unit on it, you don't have to put ice in it. So the amount of room you have in here is the actual amount of room you can use to put your food. And you can pack the food in here as tight as you can get it. And that is actually more optimal for cooling anyway. I like that this has the Eco and Max modes, so you can cool it off quickly on your AC. But then when you're running it off the battery power, you can turn it to Eco mode. So I plan on using this for picnics and camping and such. But I really like having this also as an emergency fridge. If the power goes out, if we don't have a lot of food in our fridge, I can put the vital stuff in here and then plug that into a battery to save it so my food's not spoiling. That's a really nice feature. This will also work well if I'm going to potlucks and things like that. A lot of times we take hot dishes to potlucks. With something like this, you could take frozen treats to a potluck. You'd be the hero of the potluck. You could put ice cream sandwiches in here or something, get them super cold, take the battery to keep them cold. And at the potluck where you have beans and salad sitting out all day, this is going to be a nice treat for people. So that's all I'm going to cover in this video. If you have any questions, please leave them in the comments. If you liked this video, please click like. If you haven't subscribed to my channel, I'd appreciate it if you could do that. And thanks for watching. Until next time, goodbye.